So remember, we were looking at factoring polynomials last week, and we looked at binomial factoring patterns, and then on Thursday we talked about some other ways we could also factor polynomials, right? Remember, if they had quadratic forms, we were able to, like, if we could write them in packets of something squared and something, right, then if we could make them look like quadratic trinomials or even difference of squares, right, then we're able to use all the techniques that we had in Unit 4 to solve these things, right? So that was useful. And then we ended up looking at some examples of factoring by grouping. When we have polynomials with 4 terms, then we're able to sometimes factor by grouping. Remember what our test was. We can look at these, and we just by inspection, if we've got a 4-term polynomial, if the ratio of the first 2 coefficients is equal to the ratio of the second 2 coefficients, then you know that you can factor by grouping. You just have to do it. So what about this guy here? This is where we left off. So we can see that how about if we do the ratio of the second divided by the first and the fourth divided by the third, right? So we know that 18 divided by -3 is the same as 450 divided by -75. Both of those are equal to -6. So we know we can factor by grouping. So let's just refresh our memories how that works. So what do we do here? We kind of got to start on this. Take the first group of 2, and what do we do? Okay, right. So we just to kind of refresh our memories, we factored out the GCF, right? We know that because the leading term of the first group was negative, the GCF is negative. If we factor out a -3x to the fourth, we're left with an x minus 6. And then what Maria's saying is then we know that we get an x minus 6 in the second group. We have to have common binomial factors. And so we have to just figure out what goes in front, right? And that was a -75. What times x is actually it's a -75x. We didn't quite get that right, did we? What else should I include with that? X squared, yep. Good. So -75x squared times what is -75x cubed? X, right? So it works out, doesn't it? If we got an x minus 6 here, we'd know that would have to be a -75x squared. Question so far, is that good? Okay. Now what? So what's our common factor that we pull out front? X minus 6. Good. And then we're left behind with, whoops, bad color. That's better color. We're left behind with then a -3x to the fourth minus 75x squared. And so what did we forget to do initially on this one? We can still do it. It's the point I want to make here is we can do this at any time. Well, I'll tell you what, I'll ask you that in a second. So we've got this x minus 6 that's done, right? This is a linear factor. What about this guy? What can I do with that red factor there? Say it again. Greatest common factor. Yeah, what is the greatest common factor of the red binomial? -3x squared. Yeah, right? So I could split this one up into a -3x squared, and then what's left behind if I divide out a -3x squared? Plus, right? Plus 25. And then we've still got our x minus 6. And so we'd probably want to reorganize this. We want to put the monomial factors first, right? Because that is our GCF. And so we end up with our -3x squared out front. Then we don't need it in parentheses also, right? Times x minus 6 times x squared plus 25. Is that going to factor? X squared plus 25? No. No, that would be a sum of squares, okay? So there's our final answer. What could we have done initially maybe to make this slightly easier? Yeah, we really should have at the beginning. We didn't do remember, we always want to try to factor out a GCF first. We should have probably factored that negative 3x squared out right from the beginning and made everything else a little bit smaller, right? Make sense? Okay, we good? Work and get your questions answered. There's some couple challenging questions on that second assignment, so have fun with it.